There is an ever-increasing amount of sensors and IoT feeds available to us. It is also estimated that roughly 80% of sensor data has a location component, which means there is a growing variety of geospatial use cases in the Internet of Things. This is where ArcGIS Velocity comes in. ArcGIS Velocity is a real-time big data processing and analysis capability of ArcGIS Online. Velocity uses distributed cloud processing to scale tasks, enabling you to ingest, visualize, analyze, store, and act upon massive velocities and volumes of IoT sensor data. To address these key capabilities required for an IoT platform, Velocity has been broken into 3 key components. You can ingest sensor data with feeds. These act to stream live data and perhaps visualize it directly in a map. The second component is real-time analytics. This allows you to transform, enrich, and assess patterns of those feeds. These analytics can be performed constantly and allow users to perform geofencing, detect incidents, and perform alerting, to name a few. The final component is big data analytics. These analytics can be performed as a one-off or periodically to large data sets containing millions or even billions of records. Let's take a look at a few of these components in action.
First, let's have a look at how to create a feed in Velocity. EcoNode is a New Zealand organisation specialising in creating IoT-enabled devices, including smart traps. These traps are deployed across New Zealand in remote locations. Knowing where they are and what they are doing is vital to their effectiveness. So let's see how we can create a Velocity feed that ingests data from these smart traps. You can create a Velocity feed from a wide range of sources. These include ArcGIS, cloud services, messaging services, or just an XML or JSON endpoint. Our EcoNode trap statuses are transmitted by MQTT, so let's just go to Web and Messaging and select MQTT. Now let's just set the broker details. Now, the sampling will take a while, so here, instead of using data from the service, let's just copy in some sample data. You can see Velocity automatically detects that this is GeoJSON, and then it sets the field types. We'll just make a couple of tweaks to those. We'll set the date format to a string format. Set our key fields. Set our tracking ID so we know how to track features. Name our feed. And then we're good to go. Next, let's have a look at some real-time analytics. Here, we have a feed of live aircraft locations from an ADS-B receiver in the North Island. There's a wide range of tools we can use to process the feed, including tools to calculate motion statistics or to filter based on geometry and attributes. Here, we detect when aircraft enter restricted airspace, and then we write the results of this analysis to a feature layer. When the aircraft gets below a certain altitude threshold, we also send an email alert. We can pull this feature layer output into a dashboard to see the locations of aircraft right now across New Zealand, how many are in controlled zones, and what types of aircraft are flying. Velocity provides a powerful yet simple to use interface for integrating with a wide range of sensors and feeds. Here, we've also set up feeds based on XML hilltop data for flood warnings, JSON GeoNet data for triggering responses based on earthquakes, and a feed based on tracker location data. Not only can we use Velocity to process this data in real time, but we can also look at big picture trends and analysis using big data analytics.
Okay. Big data analytics allows you to analyze at scales that weren't previously possible. So you can understand historical patterns across space and time. You can use ArcGIS Velocity to perform big data analytics on IoT data you stored in ArcGIS, such as the previous feeds we've shown, or in big data storage systems like Amazon S3 and Azure Blob. Take our EcoNode trapping example. We could schedule our big data analytic to run hotspot or clustering analysis at set intervals. This would allow our trappers to see up-to-date information on where the majority of catches or trap issues are happening. This might mean adding more traps to a certain area, or investigate what is causing malfunctions in our traps. We only have touched on a few use cases, where really there are ever-growing geospatial use cases in the Internet of Things. For example, real-time data about personnel locations can be combined with information about the immediate environment around them to help keep them both safe, gain insight from movement analytics, and optimize staff allocation. Or perhaps combining live weather alerts from Met Service with asset locations to monitor which ones are most at risk, whether those assets are fixed or perhaps a live monitoring fleet of vehicles. In the agriculture and environmental markets, there are use cases in crop monitoring and air quality monitoring. The list really goes on and on. I look forward to seeing what geospatial uses this community can come up with within the exciting space of IoT.